So next topic in quality project basic steps in problem solving. So what is problem solving? Sometimes it is not enough to just cope with the problems. They need to be solved. Most people engage in problem solving every day. It occurs automatically for many of the smaller decisions that need to be made on a daily basis. For example, when making a decision about whether to get up now or sleep in for extra 10 minutes, the possible choices and the relative risks and benefits of obeying the alarm clock or sleeping later come automatically to mind. Larger problems are addressed in a similar way. Like example, I have tasks that need to be done by the end of the week. How I am going to get them all done on time? After considering all possible strategies, one is chosen and implemented. If it proves to be ineffective, then a different strategy is tried. So there are some steps in problem solving. Identify and define the problem. Let's state the problem clearly as much as possible. Be specific about the behavior, situation, timing, and circumstances that make a problem. Collect the data. Analyze the problem. Generate possible solutions. So try to list all the possible solutions. Don't worry about the quality of the solutions at this stage. Choose a solution. So during choosing a solution, you need to try to evaluate the alternatives. That is, the next step is to go through the solutions that you already had and eliminate less desirable or less applicable. Decide on a solution, that is, choose a solution, specify who will take action, and specify how the solution will be implemented. Then implement the solution. Implement it as planned. Finally, evaluate the outcome. Evaluate how effective the solution was. That is, monitor the solution, see if it accomplishes the goal. Decide whether the existing plan needs to be revised or whether a new plan is needed to better address the problem. If you are not pleased with the solution, or if you are not pleased with the outcome, return to step 2. Some problems are small and easily solved. Others are more complicated and can seem overwhelming. Next is statistical process control. It's a method of quality control which employs statistical methods to monitor and control a process. This helps to ensure that the process operates efficiently, producing more specification-conforming products with less waste. So sometimes statistical process control is interchangeably used with statistical quality control. So a process by which a product or service is checked during its creation using certain set of parameters and statistical techniques to measure and analyze the variations within the process. So for statistical process control, generally we use control chart and run chart. So the control chart, it's the popular statistical process control tool. It was developed by Walter Sheward. This control chart helps on record data and lets you see when an unusual event such as a very high or low observation compared with the typical process performance occurs. So the control chart attempts to distinguish between two types of process variation, like common cause variation and special cause variation. So it's a graph used to study how a process changes over time. Data are plotted in time order. This control chart always have a central line for the average, an upper line for the upper control limit, and a lower line for the lower control limit, LCL and UCL. These lines are determined from historical data. By comparing current data to these lines, you can draw conclusions about whether the process variations is consistent, that is in control, or is unpredictable, that is out of control. Then comes the control run chart. It's also known as a run sequence plot, which is a graph that displays observed data in a time sequence. Often the data displayed represents some aspects of the output of performance of a manufacturing or other business process. For example, a run chart in a hospital might plot the number of patient transfer delays against the time of day or day of the week. So here is an example for the tracking improvement. See, in the first picture, you can able to see some of the processes are out of upper control limit or near to the lower control limit. That is, processes are not centered and not stable. When after making improvements, we could able to find it is almost in the middle. That is, the process centered are stable. Further improvements made, so that additional improvements made to the process so that the given process are within the middle line. The best example we can tell you the diabetic level. That is, it is the lower level is 70 and the upper level is 120. If it is above 120, then also a problem. If it is lower than 70, then also a problem. So it should be within this, it must be within this limit. Process variations. So what is variation? It's a fluctuation in the process output. It is quantified by standard deviation, a measure of the average speed of the data around the mean. Variation is sometimes called as noise. Variance is squared standard deviation. The process variability due to natural causes like temperature variation, material variation, customer differences, operator performance, it must be monitored. Whereas that of special cases like means which is unpredictable. There are certain causes which is predictable, certain causes which is unpredictable. The special causes like machine is breaking, untrained people, machine movement, and process has changed, it must be that is early and visible warning is required. What can be controlled using SVC? Variables, those that can be measured on a continuous scale. For example, the length, time, weight, everything can be easily measured. But attributes, in that attributes can be assessed only by judgment, and these are all digitonomous. That means only two states, either is okay or not okay, either is right or wrong, either is true or false. The quality as a source. The philosophy of making each worker responsible for the quality of his own work makes the quality of the final product. And Genichi Taguchi's theory of quality loss. So the Taguchi loss function is graphical depiction of loss developed by the Japanese business statistician Genichi Taguchi to describe a phenomenon affecting the value of products produced by a company. The quality loss function is defined by Taguchi is a loss impaired to the society by the product from the time the product is designed to the time it is shipped to the customer. In fact, he defined quality as the conformity around a target value with a lower standard deviation in the output. So we can tell that quality is a predictable degree of uniformity and dependability at low cost and suits to the market. Losses begin to grow as soon as the quality characteristics of a product or service deviates from its nominal value. Once the specification limit is reached, the given loss will suddenly become stable. That means positive and constant regardless of the deviation. See, if you remember that when we are introducing a product into the market, introduction, growth, and then the peak time, after that the depreciation. So this peak time or this particular area which we normally termed as the deviation means deviation from the actual expectation. Then comes the problem solving methodology. Just ask the following questions. Identify the problem and ask who. Who identified, that is, who said that there is a problem, and who caused or causing the problem, or whom it is going to affect. Or any solution had done about the problem. And second, identify the problem, ask what happened or what will happen, what are the symptoms, what are the consequences to others, what circumstances surround the occurrence of the problem, what is not functioning as desired, and ask when did it or will it happen, when did it first occur, ask where is a problem occurring, where did it or will it have an impact, ask why is this problem, why did it or will it occur, why was nothing done to prevent the problem from occurring, why is a response needed now, and then how should the process be working, how are others dealing with these or similar problems, how do you know this is a problem, and what supporting information do you have. So we can tell that there are 5W, that is 5W. What is 5W? That is who, what, when, where, and why. And we can tell that how and how. So which generally termed it as W raised to 5 double H principle. So ask what, ask who, ask what, ask when, ask where, ask why, and ask how and how. So if you get the answer for all these questions, we can tell that you are in the right track or you are in the right path. Thank you. That's all this chapter.